Sir, shall we start, sir? Khanapurkar, sir. Sir, there are 72 participants now.
Yeah, we are starting. Yes, madam, we are starting.
Okay, sir.
Yeah, Professor Anand, we are starting.
Yes, sir. Sure, we can.
Yeah. Good afternoon, participants, and welcome back to session 3 of day 1 of this 1 week online mode FGP on recent trends and applications in biomedical signal and image processing. I am happy to welcome Professor Anand R, who is a faculty of Sona College of Technology, and he is a member of Sona Signal and Image Processing Research Center, Salem, Tamil Nadu. He will be delivering his session today as a session 3 of day 1, and he will be talking on a role of deep learning for signal and image processing related to medical science. I take this opportunity to welcome him on behalf of all of us, participants, organizing team members. About Professor Anand. Professor Anand R is working with Sona College of Technology, Salem. He received his bachelor's degree from Convolutional Engineering College, Anand University, and his master's of technology in communication engineering and signal processing from Amrita University, Coimbatore. Currently, he is pursuing his PhD in Amrita University with collaboration of ISRO, Bangalore. As I have said, he is a team member in the research group named Sona CIPRO, where CIPRO stands for Signal and Image Processing Research Center. His areas of interest include signal and image classification, machine and deep learning, and hyperspectral image processing. He has got 15 plus publications in international Scopus Index journals, and he has the citations of around 86 with H index of 3. So, I welcome once again Professor Anand and request him to start his expert session. Welcome, sir. I am now.
Thank you, sir. Thank you.
I am making you presenter, and you are requested to start your session.
Sure, sir. Thank you.
Professor Anand, you are now presenter.
Yes, sir. Yes, sir. Is this visible?
Yeah, it's visible.
Yeah, thank you, sir. Thank you. Thank you for these instructions for giving me this opportunity to interact with a big variety of different colleges and colleagues of the area of research, sequence and image related to machine medical science. So I welcome you all just for second session. So today's session will be very useful for you, as well as I will show some demonstrations in diabetic retinopathy, how the medical science related to deep learning as well as. So today's session topic is role of deep learning for signal and image related to medical science. So basically I'm Anand, I'm a professor, and also I'm a research member in Sona Signal and Image Processing Center, and I already the coordinator of this program has already mentioned everything. So please note down my mail. If you have any queries, please let me know. I can definitely interact with you. If you have any, if you are facing any difficulty. Okay. So today the sessions will be seeing some basics of deep learning. Then we'll be moving to the convolutional network of what is the concept of convolutional network. How you are applying the convolutional in the medical science. That we will be doing today. So first I'm taking the deep learning applications. So what is the deep learning applications? For example, I'm taking the handwriting digit recognition. So hope everyone knows what handwriting digit recognition is First application of deep learning. See here, for example, I have a image of 2. Okay, this is a handwritten image. So I have a machine. That machine has to predict whether what is the number of this image. The machine has to be told the number will be 2. So how it will be happen? By use of deep learning applications here. So what is deep learning? Then what are the layers deep learning? How deep learning is framed? Everything will be seen clear lecture. I think this session is very, very interactive. Okay, so please look on that. Okay, so see here. For example, I have image of 2. Okay, so everyone know image will be 2-dimensional. So image will be 2-dimensional. It has two rows as well as columns. For example, my image is having 2. So the image size will be 16 cross 16. So totally 256 pixels will be over there. So what I am going to do, I have converted into vector. I want to convert into vector. That vector, what is the vector? The vector is nothing but how many dimensions, how many pixels we are having, that we have to convert into as a vector. For example, here we have a 16 cross 16 equal to 256. Okay, that I am converting it as a vector. It will be x1 to x26. So 256. So it will be 256 vectors will be there. After that, what is x1 value? What do you say? What is the x1 value? This is nothing but first pixel value of this particular data. So this is nothing but this is 1, this is 1. So this corresponding first element. What is second x2? Second first row, second column. Next x3 will be first row, third column. It will be goes on. After it will be ended here 256. After it will be 256. 256 is nothing but the last pixel. Okay. So what is x1, x2, x3? It's nothing but x1 is nothing but wherever you have a link, that will be marked as 1. But if no link, marked as 0. Okay. So here there is all the values will be 0. After coming here, it will be marked as 1. So here 1 will be goes on. Here 1 it will be goes on. So wherever you have it to, that 2 1 will be present over here. So what is my output? My output will be digit. So we know the digit will be 0 to 9. So only 10 values will be there. That is y1 to y10. So it's not, y1 is nothing but y1 is belongs to 0. Y2 is nothing but 1. Y3 is nothing but 2. Y4 is nothing but it will be 3. So it goes on. It will have to go to y9. Sorry, it will have to go to y10. The 10th one will be 9. Okay. So see here. So each dimension refers to the confidence. Okay, what is the confidence is nothing but how my image is particularly classified as a predicted value. So we can see here, for example, we know the input value will be 2. Here we know the input value will be 2. We know T should be have high confidence. Okay, y2 is 2. I mean value 2, y1 is 1, y2 y10 will be 0. So see here my input image is what? 2. So if it is a corresponding 2 in the same, definitely my output will be, the probability of output will be, definitely it will be 2, which why I am 2 in the sense, because that confidence is high. What is the confidence? That is the probability ratio will be very high compared to other digits. This is the scenario here. If the image is 3, okay, for example, if my input image is 3, the output will be 3, but third corresponding confidence should be high. So remaining all the constants should be less. So you can see here for one constant will be 0.2, 0 confidence will be 0.2. So but what is my 2 confidence? 2 confidence is 0.7. So that is the confidence value is more high. So each dimension represents the confidence of a digit. Okay, so see here the corresponding to values the dimension will be, confidence value will be 0.7. So this is the image as 2. It will be predicted. So how it will be happen? See here. So here I have this is a 2 image that I converted into vector, that is 256 per 2, 16 cross 16 to become 256. So then what is my output? Y1 to y10. Then see here the scenario is nothing but I have a index of 256 values. That 256 values I am converted into 10 values. That is y1 to y10. This is nothing but the first one. This is 2. This is 0. Y9 will be 9. Will be goes on. This is exemplification. See here, in deep learning is nothing but the functions of representation by neural network. This is the neural network. How it will be happen? This one. That will be look on the upcoming slide. Okay. See here, this is the elements of neural network. So first will be neuron. Neuron is nothing but here I have input of A1 to AK. The corresponding weight vector will be W1, W2 will be up to WK. Then I have bias. So bias is nothing but will boost up your network. Then you have a function is nothing but here. So what is Z in the sense? Z is equal to A1 into W1. So A1 is nothing. So A1 is yeah. So Z is nothing but A1 into W1. Excuse me, ma'am. Can anyone mute them? It's unwanted is coming.
म्यूट केलेला आहे का सर? सर म्यूट केलेला आहे का? आवाज येतो.
Yes, thank you. So see here. So here we have Z value. Z is nothing but the first input vector we have to multiply the corresponding weight vector. So A1 into W1, I have to summate, then A2 into W2, then A3 into W3 will be both up to AK into WK. Then finally you have to add into bias. That is the scenario for Z. So after adding Z, I want to use some activation function. So what is activation function? Nothing but that is some thresholding value. It will detect which one will be the corresponding value. For example, here I have digit of 2. So we have vector. This you have multiple some weight vector. Then you have come into the picture. The A should be 2 over here. It should be 2 over here. This is element of neuron. See here. This is the layer 1, layer up to layer L. So this is each object, each point will be carrying a neuron. Then you have a interconnector. This is the one. I have input filter. That one input filter I am connecting to all the neurons. Okay, that is the enormous neuron. Why you have to connect the enormous neuron? You get the more number of filters of each neuron. So if filters is very high, definitely the output will be better. So that's why the deep learning is coming to the last. Deep learning is playing a role in the last 5 years. Okay. So here, this output layer will be something. See here, there is the input layer. This is the output layer. In between, we have a hidden layer. So this more number of hidden layers, it means deep learning. So deep learning is nothing but you have many hidden layers. It's a scenario. Then, so how neural network is forming? So for example, see here, this is my weight vector. My weight vector is 1, 2. This is nothing but W11. This is 1. This is 2. Sorry. This is 2. So this is corresponding 1. This is corresponding output 1. This is corresponding output 2. So see here, this is 1. This is also 1. So W11. This is W11. So here W11 is coming. So here see, here that from 2 coming into 1. It becomes W21. Here it is coming 1, 2. This is W1, 2. This is nothing but W2, 2. Because here is input is 1, here is also input, output is 1. So here input is 2, here output is 2. Not input, that's the corresponding weight and memory. So here that is input vector. So here for example, what is I am trying to do in the same. So here my weight vector W11 is 1, W2 is minus 2, my bias will be 1. Same thing, W12 will be minus 1, W22 will be 1. Same bias will be 0. So here I am keeping like this. So how to find out this corresponding vector? For example, I am passing the input will be 1 and minus 1. This is my input. My first input will be 1. My second input will be minus 1. So I have to multiply corresponding. See here, 1 into 1, it becomes 1. Then here it is coming into this one, right? So what is the input here? Minus 1. So minus 1 into minus 6 becomes plus 2. Okay. Then you have that bias. What is bias? Bias will be 1. So 1 plus 2, 3. So 3 plus 1 will be 4. This is the scenario. This is the 4 is coming to the picture. Then I have to capture this also. So 1 into minus 1, minus 1. What about this? Minus 1, 1 into minus 1. So minus 1 into 1, that becomes minus 1. So minus 1 minus 2 becomes minus 2. What is bias here? This is 0. So it will become minus 2. Okay. So this 0.99 is nothing but that is your sigmoidal activation function. The sigmoidal activation function is nothing but 1 divided by 1 plus e power minus z. So 1 divided by 1 plus e power minus 4 if you are substituting corresponding 0.98. This is the scenario here. So calculate, this is what you have to calculate like this. So this is the corresponding element. This is the element of neural network. You have to calculate by using mathematics. So like this you have to calculate upcoming hidden layers. Okay. So here this is input. These are input 0.98 and 0.12 is the input. You have a vector, then you have a bias, and you have to calculate. You will get the corresponding values. Okay. See here, I am not changing any weight. I am changing input. Okay. The last input will be 1 and minus 1, but I am changing this will be 0 and 0. So you get corresponding different parameters, but the weight will be same. So what I am meaning to say, here output will be 2, the input will be 2, output also 2. So you have, first, for example, I have function of first input is what? 1 and minus 1. The corresponding my output will be 0.62 and 0.83. If my input is 0, 0, the corresponding weight will be, the corresponding output will be 0.51 and 0.85. This is the scenario. So what I am meaning to say, different parameters will get different functions. Okay, this is the main objective of neural network. This is the main application, because whenever the image is change, corresponding output also will be changed over here. Whenever the signal is changed, the corresponding signal also will change over here. Then, same operation, how you will do the matrix method. So because if it is coming to the higher dimension, definitely the matrix is playing the important role over here. So see here, what is we know the weight will be 1, minus 2, minus 1, 1. So I am changing keeping as 1. So this is 1, minus 2, minus 1, 1. This is my weight vector. Then I want to multiply with input. Okay, I multiply with input. Then I want to add in bias. What is bias? 1 and 0. So I am adding bias. So the corresponding element will be 4 minus 2. Okay, this is the corresponding bias calculation. So 1 minus 2 is the first row. Then minus 1 will be second row. Then I have input will be 1 and minus 1. Plus I want to add in bias. Bias is 1 and 0 will be corresponding 4 and minus 2. Then you have to apply the sigma model function, that is sigma. Then it will be corresponding 0.98 and 0.12. This is how you have to calculate your mathematics operation. Okay, so what is neural network? How neural network will be do here? See here, we know we have input will be x1 to x10. Then you have weight 1, bias 1, then weight 2, bias 2, then weight L. Weight L is nothing but will be more hidden layers. That is weight L and PL, that is bias L. Then see here, this is the first input. What is the first input? Sigma of W1 into X2 into plus B1. This is the first vector. Then you have to add into second. Then you have to add into third. And it will be both on. This is how you have to create your sigma model function. Then see here, we have y is equal to f of x. That is the scenario. Then we have a function like this. Okay, we have to apply sigma model over here. From the sigma model you have to give the input. Then again you have to apply sigma model. Then you have to output. Then output you have to enter another layer. Then that is the input of the new area. Then you have to apply the sigma model. That is the sigma model. So up to sigma model will be giving you the everything of your input. Okay, it will be added each bias. That is the element of neural network. Okay, that is using parallel computing techniques to speed up your matrix operation. This is the one advantage. Okay, if you are computing parallel computing, then definitely you have a speed up your matrix operation. Okay, so what is softmax change? You have Z1 is equal to some ordinary values. Then if you are applying to softmax, you get the values will be minimized. Okay, so see here. So here we have Z1. Then you have to convert into exponents to get z power z minus z power 1, then z power z power 2, e power z power 3. Then what you have done is here the probability is playing important role. That is whatever you have in the value, the values will be confidence value will be 0 to 1 only. The minimum value will be 0, the maximum will be 1. That is the confidence value. Okay, that confidence is predicting by use of softmax layer. Okay, that is the activation function. You have different types of activation function. So I am using here sigma model. So I mean soft function, softmax. You can use sigma model also. That's not a matter. Okay, this is the scenario. This is okay. So here, so how to set up your neural network parameters? So we have we already mentioned. So here this is the first pixel, this is second pixel. So that will be converted as a vector. Then you have here some hidden layers. Then you have to apply softmax. Then you will get there some confidence value. I already told if the image is 2, definitely the confidence of 2 should be high. Okay, it's not, if it is some other, for example, input image is 2, but my confidence value is 2 is not that much level. If it is my instead of 2, the machine is predicting as 4 means that will be a classification. That you have to find out the use of confusion matrix. We will look on that. Okay. So see here. So this is the details and network parameters. So W1, P1, W2, W2 is the corresponding parameters over here. Then for example, if my input is 1, the y1 should be maximum. The input is 2, y2 should be maximum. So how to relate to this? This is how our neural network will be happening here. Okay. So now we will move into the convolutional neural network. Okay. So last 5 to 6 years, the convolutional neural network is playing a big role in real-time applications. Lots of applications coming into the picture, especially in biomedical as well as normal image classifications, normal object detection. Everything is happening in the business of convolutional neural network. Okay. So convolution, for example, this smaller layer of neural network. You have input, you have 3 hidden layers, you have output. Okay, there is a small neural network CNN. So what is CNN? What do you mean CNN? See here. So CNN is nothing but it is good to learn by use of feature extraction. Okay. So what is the feature extraction? You see here. See here. For example, how CNN is happening is for example, you have one image. Okay. In that image, I have some birds. In that birds, I want to detect only the word, only a smaller part of your image. Okay. So I want to extract only a small part of it. How will extract? So by use of deep learning. How it enhance? How it in the sense I want to direct deep. Okay, that is the deep. So how it will be happen? So it's nothing but you have to apply some feature, that is filter over in your input image. You will get the corresponding big detector. We'll see how it happens. So see here. So here this is the deep will be upper part. Here this will be middle part. So this also will be easily by classification by use of filters, that is kernel. Okay. So CNN is playing important role because of kernel, that is filters. You have enormous filters you have to apply. Okay. Nowadays what is happening is a lot of already existed libraries over there. That existing libraries having the automatically take filters. But what is the risk now? Research is going on since we can apply own filters. Okay. If you are applying the own filters, different number of filters, what is the exact result is coming to the picture. Okay. This is the scenario. Okay. What is convolution layer? So CNN is a neural network with small convolution layer and other layers. Okay. So what is convolution? It depends upon the number of filters that convolving is into the operations. Okay. So you have input image, you have kernel. That is kernel is nothing but here I want to get big detector. Okay, I want to get only big detectors. If I applying the corresponding beak of a particular image or by using some filters, we extract the particular values. Okay. So see here. So what is convolution? For example, I am considering my input image will be 6 cross 6. My input image will be 6 cross 6. So if I am applying the filter, okay, if I am applying the filters, so filter has lot of filters you are having. So for example, my filter will be first consists my first filter one. So what is happening? So these are the filters. The filter size is what? 3 cross 3. The filter size will be 3 cross 3. You have to convolve this and this. Okay. So for example, what is dot product one is nothing but see here 1 into 1, 1, 0 into 1, the 0 into minus 1 will be 0. So 0 into minus 1 again 0. Minus 1 into 0 into minus 1 is again 0. Then 1 into 1, 1. Again 0. Again 0. Again 0. So 1 into 1, 1. Okay. So totally 1 plus 1 plus 1 will be 3. Okay. You have to apply this filter to corresponding this matrix. Then here what is the stride in the same? Stride is nothing but how the position of the filter you have to move into the forward. If it is stride is 1, you have to move 1 position by right side. If it is stride is 2, you have to move 2 position in your stride. Okay. If stride is 1, you get more number of features because in init picture you one information. That's the scenario. Okay. So see here. So if I am using stride, I have to multiply the same vector. So first will be what? 0. So 0 into 1 will be 0. Then 0 into minus 1 will be 0. 0 into minus 1 will be 0. Then 1 into minus 1 will be minus 1. Then again 0. Again 0. So 0 into minus 1, 0. 1 into minus 1, minus 1. Then 1 into 1, 1 into minus 1, sorry 1 into 1, 1. So minus 1 on plus 1 we can get a corresponding minus 1. Then you have to, if it is stride is 2, you have to move 2 positions. So you have to move 2 positions. You have to multiply this images for corresponding this position to this corresponding filter one. This is the convolution. This is how you have to convolution operation will be happen. Okay. For example, here I am considering stride will be 1. So here first one will be 3, second one will be minus 1. If it is third one will be minus 3. How it is minus 3? So 0 into 1 will be 0. 0 into minus 1 will be 0. 0 into minus 1 will be 0. Minus 1 into, 0 into minus 1 again 0. So 0 into 1 will be 0. 1 into minus 1, minus 1. Then minus 1 into 1 will be minus 1. Then minus 1 into plus 1 will be plus 1. Okay. So minus 1. So it becomes minus 3. So whole minus 1 becomes minus 3. So if it is successful, we move into the next one. Next, whatever you have to move one down position will be happen same thing. So this is how to do it here. Okay. So this is the matrix you have to find out here. Okay. This is the filter 1. If I have to apply second filter. Okay. Repeat the filter. Same operation you have to use. What is the first value? Minus 1. So minus 1 into plus 1 becomes minus 1. So 0 into 1 will be 0. 0 into minus 1 will be 0. Then 0 into minus 1 will be 0. 1 into 1 will become 1. That is plus 1. 0. Then 0 into minus 1 will be 0. 0 into 1 will be 0. 1 into minus 1 will be minus 1. Correct, right? Yeah. Minus 1 in 1. Yeah. It will be happening here. So what is the value? The final value will be minus 1. So minus 1 will be plus 1 will be cancelled, will become minus 1. Then it has happened minus 1. This will happen going to the picture. So that is it. This is belongs to filter 1. This is belongs to filter 2. Okay, it will be up and down how much filter you are using over here. Okay, this is how you have to filter in the that is filter map. So this is how the filter will be extracted by using filter. Okay. Okay. So for example, my image will be color. That is RGB 3 images. So what is RGB image? I have 3 images. I have 3 different bands. I have to apply 3 different filters of particular image. Okay. This is the scenario here. Okay. So see here. So here I have image. Here I have filter. Here I have output. Okay. How neural network will be doing that one? It's a very easy method. See here. So we know the images will be 6 and 6. Totally 36. Pixels will be there. Okay, 6 by 6 means 6 into 6 will be 36. So, see here, this is my first value. Okay, this is my first value. What is the first value? Here, wherever you have 1, that will be corresponding to 1. So, this is 1. This is 1, 2, 3, 4, 5, 6. Then 7. This is 8. This is 9. I mean the position of your image. Okay, so this is 9, 10, 11, 12, 13, 14, 15. Okay, see here, for example, I have image, that image I am converting into pixels. What is the first value? 1, 0, 0, that is 1, 0, 0, 0, 0. 8th value is what? Again, 1. Then, because this is 6th value. So here 6th value will be happen. Then what is 7th value? 7th value will be 0. 8th value will be 1. 9th value will be 0. Will goes on. So how neural network happens? We know the first output. First output will be 3 by applying this filter. So how it will be happen in the same? It will be connected up to the corresponding pixel. See here. Here is applying this filter to this 3 cross 3 matrix type. So what is the first value? First is 1. So here that will be 1. 2 will be happen. 3 is connected. 4, 5, 6 is not connected. Okay, 4, 5, 6 not connected because you are applying only the filter of first 3 cross 3 images. So 1, 2, 3. So 4 is not connected. What is the first next value? Up to 6 is not connected. 7 will be connected, right? So it will be connected 7, 8, 9. Then 10, 11, 12 is not connected. It will be connected 13, 14, 15. That's right. 13, 14, 15 is connected. It will be corresponding 3. Okay. What is the next output? The next output will be minus 1. So what is minus 1? So here this is 1, 2, 3, 4. 5, 6, 7, 8. This is 2, 3, 4. So it will be connected 2, 3, 4. Then 5 is not connected. 7 also is not connected. It will be connected 8, 9, 10. So 8, 9, 10. Then 11, 12 is not connected. 13 also is not connected. It will be connected 14, 15, 16. So 14, 15, 16 will be connected. This is how the neural network is happening. It will be goes on. That is sharing of weight by use of filter. Okay. This is the scenario here. So what is whole CNN? So you have input image, you have a convolution operation, you have maximum pooling that will tell you what is maximum pooling upcoming. Then what is flattened layer? Wherever you have a two-dimensional the vectors and two-dimensional image, that will be converted into one-dimensional image. Okay. So see here, what is maximum pooling here? So what is this is our filter output. Okay, this is the feature that is convolution operation output. So here I am applying this filter to applying this is filter 1 output, this is filter 2 output. So here I am applying maximum pooling. So we have these three different types of pooling: maximum pooling, average pooling, sum pooling. So mostly maximum pooling, average pooling will be playing big role. Why in the happening thing? See here. So here I want to convert into maximum pooling 2 cross 2. So that whole 4 cross 4 matrix it will be converted into 2 cross, it will be divided by 2 cross 2. From this it will be calculated which one will be maximum. So from see here 3 minus 1, 3 minus 3, 1. So from this 3 is the maximum. Okay, same thing for here also. Minus 3, minus 1, minus 3 is 0. From 0 is the maximum. Then here 3 is maximum, here 0, 1 is maximum. So same thing for filter 2 also. Here minus 1 is maximum, so here plus minus 1 is maximum, so here 0 is maximum, here 3 is maximum. So that will be converted. So what is wise pooling? So pooling is nothing but it will not change your object, it will be reduce the subsample, that is subsampling. The sample is nothing but it will be converting, have a high dimension that will be converted into smaller dimension, but object cannot be varying over there. Okay, this is the pooling. So what is the CNN compressed fully connected instance? It will be reducing the number of connections. That is the shared weight of edges. We look on that. And for maximum pooling, reduce the complexity because it's not that much difficult to compute the mathematical operation. We take the maximum particular values. Okay. So this is the maximum pooling. Have a 6 cross image that will be converted into 2 cross 2. That is 3 cross image is happening. Okay. So this is how we will look on that. Yes. Okay. So what is flattening? So flattening is nothing but after finding the pooling layer, that all the vectors will be converted into flatten. That is first 3, 0, 1, 3, then minus 1, 1, 0, 3. Okay. This is the corresponding flatten. So here it is nothing but 2 cross 2 into 2. Because this 2 cross is your image size, then you have 2 different filters. So 2 to the 4, 4 to the 8. So only have 8 layers. 1 cross 8 flatten layer. So 8 cross 1 flatten layer. Okay. This is same that you have to put the content into fully connected. Okay. So now we are looking the scene into KRS. We will have some hands on. So take care. So here my input size will be, there is a convolution, how you will be using convolution operations here. First will be convolution. Then you have applied 3 cross 3 filters of 25. Okay. So this is a linear architecture. Say my input shape will be 28 cross 28. I am applying 3 cross 3 filters. Okay, I am applying 3 cross filters of 25. I am applying 25 different filters. Okay. Okay. Then I am applying the maximum pooling. So maximum pooling setting where I am applying 2 cross. It will be converted into 3. This is how we will look on it. Okay. So see here, my input will be 28 cross 28 cross 1. Then I am converting, I am applying to the convolution layer. Then I am setting it 28 cross 21. That's into 1. 1 is nothing but black and white. So again I am applying 3 cross 3 images and I filter rate will be 25. Then that my output will be 25 cross 20 cross 26. So you have a formula that you can calculate it, the easy method. The maximum pooling will be converted to 13 cross 13. Then it will be converted again applying the convolution layer to convert into something. So here how many filters? Nothing but you have 9 filters. Okay. Here I am applying 9 filters. So here 255 filters. Okay. So filter you can apply by more. It's not a matter that much. So finally it will be converted into flattened layers, nothing but 50 cross 5 cross 5 it will be 1250. That is 1250 into 1. That is a flattened layer. Okay. So here dense layer is nothing but your output dimension. If it is digit means that will be corresponding 10 value because 0 to 9. That is a totally 10 layers. My final activation function will be of 9. Okay. Okay. So this is the general CNN architecture of application. So here we will be doing some applications of deep learning medical science image processing. So we have different applications that is encephalograms, electrocardiograms and electrocardiograms, that is EOG, ECG and EEG. So these are general applications of medical signal processing. So what about medical image processing is nothing but we have different scenarios, that is brain tumor segmentations, then diabetic retinopathy, reduction in eye images, then diagnosis of skin space. Okay. So these are the different applications of deep learning in case of medical image processing. So today we will be seeing some hands-on experience on diabetic retinopathy reduction in eye images. Okay. So what is diabetic retinopathy? It is one of the leading causes of blindness and eye disease working age population because of some overduties or something like that. So here we have two different images. For example, normal image and DR affected eye. For example, a person having a diabetic retinopathy. So if a normal image is happening like this, okay, a normal human being will be visible like this, but same images, if you have the person with diabetic retinopathy, the images will be like this. So then how will you find out the level of the diabetic retinopathy? Okay, by using some deep learning algorithm. So here we have it 5 different classes. That is class 0, class 1, class 2, class 3, class 4. So here we have 5 different classifications: normal, mild, moderate, severe, and well-threatened. Then you have normal, like mild, these are some sample images what I am taking from database. Okay, so this is the normal scenario. So what I am going to do, so we will do some hands-on. See here, so I am splitting into training and testing. Okay, so I already told we have 5 classes. Okay, this is my class 1. So my class 1 is having some images. Okay, around 134 images will be happening. Same thing for, that is 0 is nothing but no diabetic retinopathy. Case 1 means normal, mild. Okay, mild diabetic retinopathy will be there. Then 2 will be some moderate. Okay, some moderate level of diabetic retinopathy. Then 3rd will be severe. Okay, then 4th will be some other classes. This is not doing. Then this is for training. So same thing for testing also. So testing I can't use for whenever I am using training. This is a testing case. I am not using for training scenario here. So same thing will be happening here. Okay. See here. So here I am using some Python. I am using Jupyter notebook. So here first case we have to import some libraries. Okay. So here I am using Keras for importing the libraries. So first I am importing NumPy. So why is NumPy? Since if you are having higher limits of mathematics operations, NumPy is here. NumPy is nothing but numerical Python. Then from Keras import backend exchange, nothing but from importing Keras. Then I am importing the dense droplet activity layer. These are the layers, convolution layers and maximum pooling layer. Then I want to generate the image. Then I want to print the conclusion matrix into application report. Then I am using matplot for plotting your values. Okay. See here, the first will be you have to upload your training image and testing images. So I am just uploading training images, testing images. Okay. So I am just converted into 150 class 150. Okay, 150 class 150. So here my effort will be 5. And fixed effort will be. Okay. So batch size will be 1. And period batch size will be 30. It depends upon your scenario. It's not that much. So number of training samples will be 4. It's not needed. If you want, you can just give the length of images. Okay, then 4 thing, the number of exams will be 1 or 2. After that, I am generating image. What is generating image by using or by passing your how it will my images will be happen here. Okay, that is some rotations or something will be there. Why this case in the sense nothing but, for example, if my one class is small, then it will be up and it will be some data generation, that is data augmentation will be happen in the scenario here. Okay, next is what I am just converting into my matrix will be 1 divided by 25. I mean, my matrix will be min-max standardization. This is standardization. Then I am just passing the training and validation. So for training I am doing the training the info part. I am passing 50 target size is what? Image rows, image columns. Nothing but 150. Then batch size will be 32. Categorizing is nothing but if it is more than 2 classifications, that will be categorical. If it is one or two classifications, that will be binary classification. Okay, that is the class 4. Then this is my layer. So here I am just keeping first the convolution layer of 32 filters. I am applying 3 class 3. I am just passing what? Image rows and image column. Okay. Then activation function is something but I am using here RELU, that is rectified linear unit. So what is the role of rectified linear unit? Means nothing but it will be to remove all the negative values in your image. So why is happening negative images? Whenever you multiply with kernel, that is filter, definitely negative value will be coming into the picture. It will be remove that negative value. Then here again I am applying pooling layer. So pooling layer is for 2 cross 2. Okay, it will be converted into 2 cross 2. Then 32. Again I have filters. Then RLU. Then pooling size. Then happening. Then finally I will convert it into flatten layers. Then that is 1 cross 64 will happen. Then we will convert it to be 5. Why it is 5? Because of here is the 5 output. 0, 1, 2, 3, 4. That is my output. Finally I am applying the accuracy system will be softmax. Okay, in the softmax will be tell you which one will be the which actually which value will be more number of prediction. Okay, that is the confidence value, confidence level. Then I am using some parameters. Then I am just passing to my input, that is model fit generator. I am passing train data set. Then a forks, then validation. Then I am passing here. So then and finally I am building the confusion matrix. So and then classification report. Okay, if it is 0 means that will be normal size. This 1 means 1 mild tree. Then 2 means moderate DRI. Then 3 means severe DR. Then 4 means proliferatory DR. Okay, this is what happens here. So see here. So first I am just running this program. So just it will take some time because I will have importing some Keras libraries. It will be Keras nothing but TensorFlow backend. Okay. So nowadays the machine learning and deep learning training is happening with use of some GPU, that is graphical unit processor. So there are some other source of open source software will be there. Okay. So if you have, before that I want to tell you how you download the data set. Okay. So just the diabetic retinopathy. Kaggle dataset. Okay. Whenever you find out dataset, you have to go to Kaggle. So see here. So for me, I download only few images. Okay. So almost Kaggle have more. Enormous images will be there. Okay. See here. Out of 83 GB will be there. Okay. So 83.83 GB for computations will take how much time? Just look on this. So even though the accuracy is very less. Okay, even though the accuracy is very less compared to existing architecture, now the research is going on how it will be happen into the accuracy. So you can download your data set by using this one. Then after that you have train labels, you have CSV file. From the CSV file, this will be all the data will be unsupervised. You have to convert it to supervised by use of train label. Okay. So you can download your data set. If you have registered here, then you just download it, you get it here. Okay. So if you are pressing all download all, then will be download your all the files. It will take time. It will be 83 GB. Okay. So first is run. So I am running. So see here, then I am generating a report, data generator. Then I am just passing my images into corresponding values. So see here. So it is entered, found that 410 images belonging to 5 class. Okay, 410 images belonging to 5 class. Then found 103 images belonging to 5 class. Okay. Then I have a model. What is the model? First will be sequencing model. I am passing here. This is my model. Okay. Then I am compiling my network tool. This is the parameters. The last is something that is catalogical cost entropy. Okay, then RMS Pro, this is optimization. Optimization is a big role in any machine learning or deep learning applications. Okay, then metrics is nothing but I am calculating accuracy. Then I am fitting the model, that is the training. This happen. So it will take some time because it will be taken. It will be run in the Firefox. Initially accuracy will be 0.34, but losses will be 1.6 because losses will be initially very high. After some time only the losses will be reduced. Here I am keeping the battery will be getting that one taking the time. It will be run easy. Okay, so better to use GPU because what is GPU is nothing but you can go for Google Colab. There will be automatically during that time I will show some demo. So this is the open source. You can take it as it is. I mean, this is the open source. You can use your source. You can use your primary model using from this platform. I'm just creating new notebook. Okay, this is a no notebook happen. So here you can connect your section. Okay, this is the section is how you do it. Then here is a folder. Okay, here is a folder. So here you can upload your images. So here you can upload your images. Then this is connecting. Just a minute. So it's connected. That is my sample data. Then upload your files here. Upload your section storage. Then refresh. I mean, after uploading your refresh, you can take your network by drive. Okay. So here you can see. So here you see here. So while connecting your Google Colab, it is connected to Python 3 Google Compute Engine backend. So what is the RAM here? 0.74 GB to 12. It is connected 12. What we are allocated for 12.72 GB. Instead I am using 0.74. Then what is the disk? This will be 107. Okay. After running this program, you can download your code. Okay. Okay, you can write your program here, so import. So here no need to install your program, install your libraries. It will be already existing libraries, so all the existing libraries will be happen here. So it will be easily running by use of your GPU. Okay, then Microsoft Azure is there, then Amazon EC2 is there. A lot of open sources will be there. You can use by using you can use the applications like for training your images of medical something will be there. Okay. Okay. Here it is locally running. We are applying some GPU test, it will be fast. Okay. If it is accuracy here, it will be only 0. Not that much here. It is 0.4 happening. If it is more effort, definitely iteration. It is more iteration should be very good accuracy will be achieved. But still now the diabetic retinopathy images having around 80% of accuracy one is validating. Okay. It's not that much certain level because of images. Okay. So see here, you can see here itself the losses will be reducing. Accuracy will be slightly increasing. You can download any data set in Kaggle. Okay. For example, I'm just taking healthcare. So here, lot of applications will be there. Data set. Then recently we have a COVID test also will be there. You can check it. COVID pneumonia. Okay. So here. So here also will be there. You can use here also, you can use of GPU. So see here COVID-19 data set. This is all the data set is almost 90 to 70 for 90 to 80, 80 to 90% of the data sets are valid. Okay. It is uploaded by cable. You can download the data set by using register. It's not that much, it's not such cost. The free version can download it, can do some research over there. Okay. So analysis, full analysis will be here. So this is the prediction of your death ratio of expecting of different countries. See here COVID-19 CT scan, that is textile images. So from this one is a lot of research is coming to the picture. So here we have 7.3 GB. This is a mask images, okay? The mask also will be there. The segmentation process happen. You can apply your some deep learning or applications, deep learning algorithms, and get the corresponding output. You can go for Google dataset also. Dataset search. There also a number of datasets will be there. For example, I'm typing. So here it will be happen. Here also it will go into Kaggle dataset. But here what is the Google dataset? It will be wherever in Google having that. Kaggle is one platform to download a dataset. Like that, there is a lot of platforms will be there. All the platforms will be coming into the Google dataset research. Okay, you can download whenever you want dataset. All the descriptions also will be happen here. Okay. Yeah, his download is completed. So say you say my accuracy will be 0.44. This mode of definitely will be increased because I have kept only 5FO. So you can see here the losses will be slightly reduced, my accuracy will be slightly increased. Okay. So definitely if the algorithm is working properly, it's not converted in mind, it's not underfitting or overfitting or it should be normal fitting. It should not be underfitting and overfitting. Underfitting is nothing but if have all the images will be client or that is overfitting. So underfitting is more number of misclassifications will be happen here. So here slightly will increase. Then I am using a confusion matrix. Okay. Why you want confusion matrix in the sense? It is a confusion matrix will play a big role in any type of image classification kind of thing. So why it is while seeing the confusion matrix, we can predict how our algorithm is working properly. So it's nothing but, for example, I have 5 different classes, that is class 0, class 1, class 2, class 3, class 4. So for example, I am giving my images to my input images to be belong to class 3. My output is predicted as class 3. Then my accuracy will be good. But instead of class 3, my class is predicting the class 1. It should be mispredict. It should be a misprediction. So that you have to avoid by use of some fine-tuning your algorithm. Okay, that is the safety here. So here I just this is the confusion matrix. Then I am creating the classification report by using calculating the precision recall F1 score. So if it is 0, it is normalized. That is 1 means mild DR, moderate DR, 3 means severe, then 4 will be proliferatory DR. Okay, so here I am using a predictor. Okay, here and there you can brain generator. Here is your predictor. Okay, so my confusion matrix will be coming into the picture. As well as accuracy, everything will happen. Sorry, I get this battery. Will take time. Okay, battery should be valid with examples. Okay, this is scenario here. Okay, I will share that file to you. You can look on that. Not that much difficult to compute a classification problem here. So what I'll keep properly too. You can save your model, you can look on that, you can find your algorithm, then you can apply that model. Okay. You can see, look, you can just look on that what is how much accuracy you are getting here, if how losses will be reducing or not. If losses is not reducing, then there will be problem in your architecture. If its accuracy is saturated, then definitely will be the underfitting or overfitting. That is always how to look on that. That is CNN is the major problem in overfitting as well as underfitting. As a researcher, you have to do some tasks in the sense, for example, you can say how different way to approach your algorithm in this kind of action, medical image processing in the sense. For example, here we have played convolutional network. In the convolutional network, what is my goal? You can change, you can fine tune your existing architecture. Okay, so here have many existing like Nature, which is in Google Nature, then Nature, as well as inspection layers, and everything, inspection modules. Enormous layers will be happen here. You can apply any kind of network architecture. Happening, whether through the or some other way, or you can train your own architecture. Everything will be there. Not here.
सर आइए इधर, लॉग आउट कर लिया, उसे लॉग आउट कर लिया। लॉग आउट कर लिया आनंद सर ने। क्या करना है, आप क्या कर रहे हो? वो काम छोड़ दो फिलहाल। आका मैडम को बोलो उनको कॉल करने के लिए।
Sir, I have called, sir.
हाँ हाँ, yes,
He is about to join. He will join again.
yeah,
There was network issue.
okay, okay.
हाँ.
Am I audible? I mean, at your end, madam?
Yes, sir. Yes.
Dear participants, please bear with us. There is some issue at Dr. Anand's end. He is trying to rectify it and he will join as well. Please stay back. He will be joining soon. We have contacted him. He is again logging in.
Sir, Professor Anand has joined again.
Yeah. Let him join completely. I will make him presenter.
Yes.
Yeah, Professor.
Sorry, sir, my name. Yes, sir.
So if everything is fine at your end, I am making you presenter.
Yes, sir. Okay, sir. Okay, sir. And it is disconnected. Sorry.
All right, this thing happens. Presenter.
Yeah, thank you, sir. So here you can see your confusion matrix here. So here we can see that much not that much happening for training your algorithm because a lot of mistakes is happening. So it's nothing but here the first class will be 0, 1, 2, 3, 4. So this is 0, 1, 2, 3, 4. So 0 image is credited as 20 is partly casted, 14 is credited as true. Okay. What is the second? So, for 1 it's not that much classified properly because 1 is having only less number of images. When you have this some data accommodation, you have to improve a algorithm. In third case, for class 3, out of out of 34 images, 19 was crediting as 1, 13 images crediting as 3. So this is how the confusion matter is happening. You have to do it here. Then, for example, I have precision recall, this is a classification report. So, for example, normally I have precision 0.33, then I have a recall. Recall should be very, very much.
ये कर रहे थे पहली साइड को अच्छा ही होगा नहीं पर बाद में सर ने जब शेयर किया था पहला साइड अच्छा दिखा था बाद में का साइड अच्छा नहीं आ रहा
So, can you, ma'am, mute, ma'am?
Yes. Khanapurkar sir. Khanapurkar sir.
अच्छा ठीक है मैं थोड़ा
Mute yourself. Khanapurkar sir.
हाँ यस
Mute yourself.
यस
हाँ.
So here we have a 5 classes, that is 0, 1, 2, 3. Each class is having the precision recall response code. So by using this also you can do some research. How my algorithm is properly execution. And find my accuracy to be 0.32. It's not that much accuracy for doing this experiment. So if I just increase the epoch, definitely accuracy will be improved. Here I am just giving 2 epochs. It will be very less accuracy because so if you are increasing an epoch, definitely your algorithm is working properly. So this is how to do your classifications of the interpretability by using some image processing. Okay. So this is the import we used here. So we done this one. Okay. Thank you. So I completed the session. If you have any queries, so please let me know. Kalyani ma'am, I finished, ma'am.
Yes. We can ask the queries and questions.
Yeah. Yeah, I think one participants asked how to apply deep learning algorithms to unpaid instance. That's a very good question. So starting with easy here. For example, I have you have a music signal. Okay, music is one-dimensional signal. So for example, just consider music signal. Okay. So the music signals, what they have to do is that music have to convert it into spectrogram. They have to convert it into spectrogram. That will be converted into 2-dimensional. That is the one way. Okay. Have input image and input signal, that is one-dimensional signal, that will be converted into spectrogram, that becomes 2-dimensional. Then you have the same problem. And you also can do the same thing. Okay, you have EEG signal, that signal you have converted into spectrogram, then you can apply your deep learning model, then you get the corresponding output. Okay. Yeah. Is there any other doubts?
सर पार्टिसिपेंट को म्यूट कर लीजिए थोड़ा
Can we use deep learning in nanoscale basically now? Most simulation. What is the test accuracy? How have we shown only the validation accuracy? So test accuracy is validation. I mean, for example, I think Shubhana asked what is test accuracy and validation accuracy. For example, you have any 1,000 images. Okay, for example, you have 1,000 images. In the 1,000 images, I am splitting into either you can see for 6:4 ratio or 7:3. Not that much 8.8:2. 8:2 is not that much good research work in your doing. Okay, 7:3 is okay. 6:4 is a better way. Okay. So 6:4 means 1,000 images out of 600 images I am making for training. The remaining 400 images for testing. Okay. So whenever you are using the classification report, it will be coming into the testing report, the testing accuracy only. Because we are passing only the testing samples. We are not passing the training samples. Okay. When calculating the confusion matrix itself, you have to give the input only testing samples. Because testing samples we are not using a training perspective. Okay, if you are applying training images to testing, then definitely accuracy will be more. Not that much good work here. So testing accuracy, you cannot use your that images you should not use in a training. That will be test accuracy. And how to get extra blood vessel growth with or by deep learning? So extra blood vessel growth in the sense you can take the, for example, you have a RGB channel. Okay, so you have a color image. Okay, for example, you can take a diabetic itself. So diabetic have a color images, that is RGB. Just extract RGB images as a channel, channel B channel, green channel. Okay, just apply the deep learning algorithm each day and a single channel. Then you will get the different blood vessels happening in your diabetic itself. That is a feature extraction. That is feature visualization. That you can do it. Yeah, deep learning for extracting skin position. I'm not sure about that. Extracting skin position. Sorry. Position, I don't know. I'm not sure about that. But you can extract. You can use signal. You can find a deep learning based skin diagnosis. That you can do it. So you have a data set in Google itself. So how to control a deep learning algorithm features. Control is happening by using feature extraction only. If we are applying more control, definitely our model will increase the complexity. Computation complexity will be more. Because if it is a feature, for example, I am applying 32 features in a particular images, it will be happen not that way. Instead of 39, I am applying 132 or 256 will be having more features. So that you cannot control it. Control here is not a parameter to here. So it's deeper, that will be deeper layer. That is, you have many layers. They have many features. Okay, if you have many features only, you will get the good results. Okay, so for example, what is the major difference between CNN and ST? That is support vector machine. Okay, support vector machine is a big role of a machine learning, a big classification. But that has small drawback. What is the drawback in the sense? If the class is bigger, more than 10 to 15 classes, the ST is not a big group, they are playing big role. CNN only playing big role. Because we have only a single having a linear, non-linear stream that will be based on some kernel. So if it is 10 to 5 classes, then it will be the stream is okay. But CNN will take some time. So you can write deep learning program using. Yeah, of course you can write your deep learning program using MATLAB. You cannot write your program means in MATLAB. Okay, because already you just download your updated version of MATLAB. Where you have a deep learning toolbox is there, just scripting your layers, just design your layers, then you can just automatically code will be computer picture. Okay, it's not that much different. So what is the difference between Google Net and Alexander? It's not, Google Net having Alexander having 11 layers. Okay, the input rate of 227 plus 227. Google Net, why it is happening? Google Net is having instruction model everything. Okay, so what is instruction model say? It is here in the Google Net only they introduced the 1D convolution. Okay, so in Google Net only 1D convolution is happening. So 1D convolution, remaining all the Net it will happen 2D convolution. But Google Net having the 1D convolution, it will be easy way process your feature extraction. Which parameters are considered in diabetic neuropathy? Especially my point of view will be considered precision F1 score recall. All the biomedical applications F1 score precision recall. This is more than enough. No need for specificity sensitive like that. My point of view. How to decide the value of hyperparameters? So parameters that will be under code. Hyperparameters you have to design by yourself. It depends upon the application can vary. Okay. For example, if it is normal image classification, the hyperparameters that will be playing in the learning rate. Okay, can fix the learning rate. But here how to decide the value of hyperparameters? Generally the value in the sense I think the learning rate something will be there. So learning rate is estimated can just keep 0.01, that is more than enough. Then please throw some light in the scope of hyperspectral image processing in medical imaging, specifically optical domain. Hey, please some light.
Let me come in, Professor Anand.
Yes,
participants, we have one this session on hyperspectral image processing. Maybe tomorrow or day after tomorrow.
Thank you.
Yeah.
So what are the possible categories of features of plant leaf images? It depends upon the images. Okay, possible categories there will be, for example, if you have leaf classifications, particularly different diseases will be happening. So it is, for example, you have a apple tree in the apple leaf, it will be different diseases will be there. The disease will be how to extract different features. It depends upon the images which plant you are considering. How to form constitution matrix?
Professor Anand, there was one question for me also. Like it was for coordinators like are we going to provide the session materials? Dear participants, we are going to provide session materials to all the participants. We will mail it as soon as session gets over. Please don't worry.
Yeah.
Go on, sir.
Yeah, thanks. So how to form confusion matrix? Since I think I told in the program itself, so confusion matrix will be telling you how our algorithm is working properly, testing the properly, especially for testing it properly. Then just write a 2 to 3 line code, then you will get the confusion matrix, then you can extract your parameters. In scope of deep learning in biosignal processing, that's what I told you. You can take, for example, if you have ECG signal, say we have to extract peak RFT, that is the peak value of your ECG, that is hot, right? That also you can predict your future extraction using deep learning. Difference between GAN, that is a GAN in the sense is under CM only, is not that much different. Not that much difference is there. Yes, the difference is there, but especially for medical diagnosis, we can use for CNN. Because we have a biomedical image for something, it will be CNN will be better. So adaptive neural network having good advantages because you have a feedback network. It will take some time to compute your devices as well as compute your images. It will take time because it will be adaptively changing the user of network. Okay, that is a CNN. I think so. So any other? Yeah, that's what are the possible categories of features in of a plant leaf images? That's what I told. Okay, it depends upon which leaf you are taking. Okay, you can just type in plant leaf images in Google. It will be going to on the first page. You have lakhs of images will be there. Okay, you can download it. Any other? So what are the recent research challenges in DR? Yeah, you can just type a diabetic retinopathy research in Google. It will be going to IRCID challenges. Every year they will be providing new images, new set of DR images. That is very difficult to classify. You can just look on that. Just keep that images how will the research will be happening. Okay. Now last 2 to 3 months before, last 5 to 6 months before, the Google has launched the diabetic retinopathy detection devices by helping using deep learning only. Okay, just keeping the eye itself, the camera will be detecting whether the person having the diabetic as well as the level of the diabetic will be predicting. That is also one type of research. Just to find out how much error is happening, that you can just fine tune your algorithm. That will be happen. Any other doubts? Thank you.
Professor Anand, you can stop sharing your screen at your end.
Sure, sir.
Yeah. So if questions are over, thank you very much, Professor Anand.
Thank you, sir. Thank you.
Yeah. Dear participants, we have gone through this session. Professor Anand has hold your hand, I should say, and gently took you through deep learning and neural network, and he made you to some extent up to convolutional neural network. and then he landed upon diabetic retinopathy and image processing applications of into it. He also shown you some online demos with the help of Kaggle database and made you through Google Colab. And thankful use for providing this insight into biomedical signal and image processing aspects with the help of deep learning. This definitely will help participants to take away themselves in the area of this deep learning as far as biomedical signal and image processing is concerned. I hope they will take you to their students, will be helpful for their own research also. And thanks for sharing your research experience with all of us. Thank you very much.
Thank you, sir. Thank you, sir. Thank you.
Thank you very much. Keep in touch.
Sure, sir. Sure. Thank you.
Yeah. Well, dear participants, it's day over here. We will be posting you the session materials of today, and hope all of you have enjoyed today's session. We had 2 sessions today. One session is left out with us. We will be taking it up in due course of time. As I have said, we will be posting you the session material. Through WhatsApp group, I could realize that there were some issues as far as joining is concerned, but I hope in due course of time those might have got solved, or in due course it will get solved as such. In the morning it was first session, so most of you might have faced some of the other difficulties. We tried to resolve it if it would have been at our end, but nevertheless, do join us for tomorrow's session at 9:45, 9:50. Stay home, stay safe. Have a good day. Thank you very much.